this video we're going to look at calculations for half-life. First of all, the general equation for calculations involving half-life is A equals A naught multiplied by a half to the power t over t a half. In this equation, A and A naught can either be the number of atoms, the mass of the isotope, or the activity. A is the final and A naught is the initial of any of those things. So for example, A could be the final number of atoms and A naught would be the initial number of atoms. T is the time expired and T a half is the half-life of the isotope. An example question would be something like, technetium-99m has a half-life of 6 hours. How much of 100 grams as a sample would be left over after a day? So the data that we have for this is our A value, which is our final activity or our final mass in this case, we don't know. Our A naught value is 100 grams. Our time is 24 hours and our half-life, our T a half, is 6. So using the equation A equals A naught multiplied by a half to the power T over T a half, we come out with A equals 100 multiplied by 0.5 to the power 24 over 6. So if we do this in our calculator and we have 0.5 to the power 4, 24 divided by 6 is 4, and we times that by 100, we get an answer of 6.25. So our answer in this case would be 6.25 grams. The final mass after a whole day would be 6.25 grams. If we have to calculate time in the equation, we have to rearrange the equation and then use logarithms to remove the power. The first thing we'll do is to rearrange the equation to leave the power term on its own. So that leaves us with A over A naught is equal to a half to the power T divided by time a half. In order to remove this, we need to log both sides. That then gives us log A over A naught equals log a half multiplied by time over time a half. So the time over time a half is no longer a power. We can then rearrange this equation and solve for T. So on rearrangement we would have T equals log A over A naught divided by log a half multiplied by the half-life. If we now look at a question involving this, a sample of phosphorus-32 has an activity of 151 becquerels. The half-life is 14.3 days. How long until the activity becomes 20 becquerels? So from this question, we know that our final activity is 20 becquerels. We know that our initial activity is 151 becquerels, and we know that time a half is 14.3 days. So quite simply, we use the equations on the left, we rearrange to leave the power on its own again, as shown here. We log both sides. This brings the power out, so we get log A over A naught equals log a half multiplied by time divided by time a half, just here. Then we rearrange to get T equals log A over A naught divided by log 0.5 times T a half. So if we substitute these numbers into that equation, we will get T is equal to log 20 divided by 151 divided by log a half times 14.3. And our answer will come out at 41.71 days. Now, unusually in physics, I've left the time for the half-life in days. Because I left the time for the half-life in days, our final time for the decay to decrease from 151 becquerels to 20 becquerels is also in days and comes out at 41.71 days.